Hello, Maurits here. Today we would look at this thing, a HAL element, a little device that you happen to own a few of, even though you don't know it. I will explain later on where they are. This is a little crystal, geranium crystal. We will put a current through here, and we will measure voltage across those two. This is a trim potentiometer that can adjust so the voltage initially is 0 over here. And what will happen here is that if we put a magnet close to this, we'll get a magnet field through this, going through this. We know that when an electron is moving downward, say from this direction, actually the current comes from that, so okay, the electrons comes in from here, the current is from that direction, the electrons this. And if I have a magnetic field here in the right direction, the electrons will start to curl, or move in a curled path, and they will, say, reach that end, and then going through this, through whatever measuring device I have, back to there and in over here, and then up again. So the electrons comes in and move in a path either in this direction and that direction, depending on the direction of the current. Now this is a geranium crystal, and actually you have something called holes moving that direction and so on, but let's not make this overly complicated. So instead we just connect this and see what we can get. First I will measure the current across here, so we get to say about 30 milliamps. So I turn on my, we'll put that to milliamps. And let's connect this here. So now we have basically very little current. And I will turn up my power device. Well, actually what we can do is measure the voltage at the same time. So let's see what voltage we have across this. I'll set this to voltage. See what we get. I'll slowly crank up my voltage, and as you see I get some current through there. It shows negative, so let's just switch these two so we get a positive value. Doesn't really matter. This is the current. The AC current in this instrument also shows the DC current, but we don't care about that for the moment, being it's so small also. Okay, let's crank this up to about 20 milliamps. No, 30 milliamps. So somewhere close now. Let's put this as close to that as possible, just for the sake of it. It doesn't really matter right now. Oh, that's quite close. So we have 30 milliamps going through here. We'll turn this off. We don't need that. We had, oh, actually we can see what voltage we had. We had about 2.7 volts. Okay, let's turn this off. We disconnect this. And instead what we do is we change this to measure the voltage across here. So that means that I need to disconnect this wire, connect my lead directly over there, and then I will measure the voltage across here instead. I put this to millivolt. So there we have quite many significant figures. So let's measure the voltage across here. And initially we should basically see about 0 volts. We can actually make this to become 0 volt by adjusting this potentiometer. So we put it very close to 0. It's hard. The sensitivity of my instrument is too high for this rather crappy potentiometer there. Okay. Okay, let's say this is 0. I have a stack of magnets here, and you can see if I put these magnets closer, I will get a current. If I rest this on top, I get about 170 millivolts. Use a minus if I turn this over, so the polarity is the opposite. I get about 170 milliamps, but in that direction. And you can see that the current varies with the voltage varies with how close I am, so it varies with the strength of the magnetic field. If I take the magnet and put it like this, very little voltage, and the same thing if I put it across like this, very little, because we need to have the magnetic field going down through here so the electrons don't move along the field lines. Okay, I said you had a few of these, and I think you can guess where. You have at least 3 of these in your phone. At least if you have a magnetometer, if you can go in and see the direction to north in your phone. So you have a compass. These 3 are set in this direction, that direction, and in that direction. So they can measure the magnetic field in all 3 spatial dimensions. And they are very small, of course. This is very big, but in your phone they are in one chip, and the whole thing is very, very small. And it's very cheap. It's mass produced, so because every phone has one of those. It's really cool, and it's actually rather accurate, the one you have in your phone. I thought I would show this because it's an example of an application of what we learned, and it's such a nice idea. Anyhow, put this on top here. See the we shouldn't end at something negative, right? We should end at something positive. So on that, we'll end the video. Hope this was somewhat fun. Ciao.